Okay, so first part is just a review of yesterday. So your greatest common factor is 14x. So you remember you're dividing everything by 14x, but you show it out front. I'm just going to move it down actually. And what are you left with? You have to divide both terms. So that'll be 2x plus 1. So sometimes when your greatest common factor is the last term, some students make it 0. They make it disappear. Remember, if you start out with 2 terms and you're common factoring, you still have 2 terms in the brackets. Okay? Start with 3 terms like the next one, we're going to have 3 terms in our brackets. Now this one here is not in descending order of degree. I'm actually going to rearrange it. So my highest degree term, and then these two are both degree 2, so I'm just going to put the sort of alpha order, so plus 6a squared minus 3ab. And so then when I common factor, I want to have a negative, because I want in the brackets there to be a first term being positive. So I'm going to put negative, and I take a look at 12, 6, and 3. So 3 is obviously common. I've got a cubed, a squared, a, so a is common. And then b, the middle term has no b, so b is not common to all of them. So it's just negative 3a, and then I am basically dividing all this by negative 3a. So what am I getting? Well, I'm getting positive 4a squared b minus 2a, and then negative 3's divide out, a's divide out, so plus b. So I put it in descending order of degree, and then I factored out negative 3a. Okay. You can check, nothing else is common in the bracket, so you know you're done, right? You got the greatest common factor. And then this was the very last part of yesterday's lesson. Take a look at the brackets. They're exactly the same. So I'm going to factor out the x plus 3. And what am I left with? I'm left with whatever the coefficients are, 2x plus 5. Okay. And that's really going to help us, not so much today's factoring, but tomorrow's factoring by grouping. Okay. Okay, next part is also review. Expand and simplify the following. So all the terms, all of those will have 4 terms. They might simplify to 3 or even 2 depending on what they are, but I want you to expand those out. Okay, spend a couple minutes doing that right now. Okay, so those are all expanded and simplified. As I said, if you can add those like terms in your head, you don't have to show any work, just the final answer. Really, it's a 1 mark question, right? Each of those. So now we want to look at the relationship between this answer form, the simplified form, and the original question. All of those originals were in factored form. Remember, we talked about that yesterday. What is factored form? There is no adding or subtracting in the expression. Maybe inside the brackets, but not within it. So that's x plus, the first one is x plus 2 times x plus 3. The factors are the 2 brackets. So we want to look at the relationship between, math is about patterns, so take a look. So our constant term is 6 here. Our 2 terms, second terms in the brackets, multiply to 6, right? That's how we get it. 30, those multiply to 6. 12, those multiply to 12. Negative 8, they multiply to negative 8. So if we're going from this simplified form to factored form, we know the last terms in each of the bracket have to multiply to that constant term. What else do we know? Guys, can you listen, please? Take a look here. This is 5x. Well, this was 2 and 3. 2 plus 3 is 5. Here, 5 plus 6 is 11. Negative 3 plus negative 4 is negative 7. 2 plus negative 4 is negative 2. So in order to go from this form back to this, we need two numbers that multiply to the constant, negative 8, and add to negative 2. Obviously, there's other factors that multiply to negative 8. You could have a negative 8 and positive 1, but negative 8 and positive 1 doesn't add to negative 2. So by looking for the pairs of factors that multiply to that constant term, we want to find all the pairs and see which ones add to the middle term. And that's how you know your factored form. Okay, so we'll practice in a sec. Let's do a little, oops, what happened there? A little summary here. So factored form is x plus r times x plus s. What do you notice about the factors and their simplified form? What is the relationship between r, s, b, and c? So remember that constant term c, it's equal to the product of r and s. So you can actually just show it as c equals rs. And then b was, so that constant, that x term, the coefficient, is the sum of those two values. So b is r plus s. Okay, we're going to summarize. I'm not going to write it out in words because we're going to summarize on the next page, but that's really what you're looking for. So to factor the next ones, first thing I want you to look at is, can you common factor anything out of these? So make sure there's not x's in all the terms. If there is, factor it out. Make sure that there's no common number factor. Well, if they're starting with x squared, there won't be, right? Because that's just 1x squared. So then you're going to look for, we know that the factored form has two brackets of binomials that both have x to start. Okay, so take a look at the previous ones. And we look at this, we need two numbers that multiply to 5 and add to 6. So I've just put in little dashes there. You could put brackets. Always start with the factors of 5. Well, what are the factors of 5? 5 and 1. That's it. Or negative 5 and negative 1. But 5 and 1, check it. Is 5 plus 1 6? Yes. So those are your numbers that you put in the bracket, and you're done. Okay. There's a method called decomposition that you can use, but you really do not need to use that for simple trinomials, and I don't want you to. Okay, you're in Math 10 now. You should be able to see these patterns and come up with the factored form of a simple trinomial just by looking for those numbers. No work needed, right? So these questions are really right or wrong. So it's x squared to start. So x in each of them. And so we want two numbers. You can use brackets if you want, that multiply to 12 and add to 8. Or you can use dashes, or you don't even have to write them down. I don't care. But you need to think about those numbers. Always start with the factors, never with what adds to 8, because what adds to 8 would be an infinite number of things. Easy ones, 1 and 7, 2 and 6, 3 and 5, etc. But you could have 100 and negative 92, right? So infinite for that. We always want to look at the factors. There aren't an infinite number of factors of 12. So go through. If you need your calculator, do it. 1 and 12 doesn't work. Write them down if you need. 1 and 12. Nope. 2 and 6. Perfect. 2 and 6, and you're done. So this is plus 2 plus 6. Tolo, questions? Okay, next one, two brackets. So we already know it's x. Now this one, oh, I don't need an equal sign there. We're going to be done this. So this has a negative, right? So we have 15 equals the product of two numbers, and negative 8 equals the sum of two numbers. So take a look. The sum has to be negative. The product has to be positive. So are those two numbers that you're finding both positive, both negative, or one of each? Both negative. Both negative, because they have to multiply to be a positive. So they're both negative. Think of, so 15, 1 and 15, you know, both negative. That's not going to work. 2 doesn't go in. 3 and negative 3 and negative 5. Perfect. It works. So minus 3, minus 5. Two brackets. Doesn't matter which bracket you put the minus 3 and which you put the negative 5, minus 5. Okay, this one, now our constant is negative. So that means one of the factors is positive and one's negative. Okay, so we know that. And our x term is negative. So that means basically of the two numbers that you get that are factors of 21, the bigger one will have to be made negative. So think of factors. So you might not put the negatives into your factors if you're writing them down. You might just go, okay, 21, 1 and 21, 3 and 7. Well, and that's really it, right? So taking a look here, one of them has to be negative, and I want them to add to negative 4. So the 7 needs to be negative there. So 3 and negative 7. Just check it out. Make sure you get negative 4, and you do. So this will be x plus 3, x minus 7. Okay, I want you to try the next two. Okay, so some of you are getting confused with A. So when you're looking for factors here, you're looking for two numbers that multiply to 7 and add to 6. Well, only choice are 7 and 1 or negative 7 and negative 1. So if I put 7 and 1 in there, that doesn't work to add to 6. And if I put negative 7 and negative 1, it doesn't work. Okay, so it would work if the 7 was negative, but it's not. So this we say not factorable or can't be factored. Or cannot factor, something like that. Okay, next one you should be able to, next one you should be able to, next one you should be able to. So I'll give you that. That one you should be able to. That one you should be able to. Okay, so brackets here. X, two numbers that multiply to 14 and add to 9. Well, 14 is 1 and 14, 2 and 7. And so 2 and 7 is the only one that makes sense. Two numbers that multiply to negative 13, add to 12. So one has to be positive, one has to be negative. Just start with any factors of the positive. 13 is a prime number, so 1 and 13, which one's negative? Has to be the negative on the 1 because this is positive. So that's minus 1 there and plus 13 there. Okay, and this one, when there's, folks, listening please, guys. So when there's nothing in front of the x, it means it's a 1, so that's subtract 1x or negative 1. So we need two numbers that multiply to negative 12, add to negative 1. So again, forget the negatives to start, just get your factors out. And so So anytime you have an x term that's a 1 or -1, you know the two factors are close together. They're 1 apart. And so here, the ones that are 1 apart are 3 and 4, where the 4 would have to be negative, so that when we add those together, we get -1. So that's going to be +3 and then -4, or vice versa. Okay. Okay, so x is here. Factors of 24. So 1 and 24, again, I leave out the negatives to start. 2 and 12. 3 and 8. Oh, and then stop there if you find it, right? 4 and 6 is another pair. But 3 and 8 add to a positive 11. If I make these both negative, they add to -11 and multiply to positive 24. How can you check your answer without just redoing it again?
You solve.
What do you mean by solve?
You do x minus 3 times x minus 6.
Yes, expand back, multiply back, use the distributive property. That's the easiest way, and when we get to some harder factoring ones, that's going to be a way of helping us figure them out. Okay, and then the f here, so 60, that's a big number. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, getting close, right? Both of them have to be negative. Computer to catch up. 5 and 12. Is that right? 50, 60? Yeah. And then 6 and 10. Okay. Now, you may have got 6 and 10 right away. You don't have to show this work. You can just put them in. Now, 6 and 10, they both have to be negative, because they both have to add to a negative, but they multiply to a positive. Okay, so they'll sometimes be numbers that you think work, but they would if they were the opposite sign. So you have to really, be good at your factors. That's why we did that unit first. Okay, so flip to the next page where the summary is. So factoring trinomials of this form, and so we call these simple trinomials. And reason why it's called simple, because the coefficient is a 1 there. Okay, 1x squared. We don't even show it. And there could be other trinomials where you have x to the 5th, or x squared, or y to the 5th, y to the 10th, whatever. But simple trinomials are in that form: x squared, x term, and constant term. Okay, or it could be x to the 4th, x squared, and constant. So they're of that particular form. They factor into these two factors, where we know that r times s is equal to the constant term, and r plus s equals to the coefficient of x, b. So we need to find, what I always say, I don't use r, s, c, b. I use this last statement. I need to find two numbers that multiply to the constant term c and add to the coefficient b. So I just say those things, and if there's numbers there, then I say them out. Okay? So we had in the last example, did we have any that couldn't be factored? Correct, we did. Can all trinomials be factored? Well, no, we already had one that we couldn't, and there's many more. So now that leads us to a little bit more challenging question here. It says list all possible positive values for k so that trinomial is factorable. So remember what we know, that the two numbers have to multiply to the constant term. So k has to be the multiplication of two numbers, and they, in this case, would have to add to 7. Okay. So there's going to be more than one choice for k. They have to add to 7, and it says positive values. So that helps. If there was positive and negative, that's the case where there'd be infinite number. But who can give me two numbers that add to 7? 1 plus 6. What's another one? 5 and 2. 4 and 3. Okay, so 1 and 6, 2 and 5, 3 and 4. That's what you gave me. Those, if we keep them all positive, then they all add to 7. Any other combos would be negatives, and we're not dealing with fractions. We probably should have put in there natural numbers, okay? So now, if that's 1 and 6 goes in here, then our k would be 6. If 2 and 5 goes in there, our k would be 10. If 3 and 4 goes in there, our k would be 12. So those are the possible values of k that would make it factorable. Okay, so there's 3.
We have to show all of them.
Yeah, it says list all possible values for k, so we've got 3 of them there. Okay, so now, question 6, we're going to combine yesterday's work and today's work, and it gives you a hint. After this, we're not going to give you a hint. Always look for common factor first. That is the rule, okay? So taking a look here, we gave you that hint. So first step, now we're going to need more than one step. Common factor between all of those terms. Who can tell me what goes into all of them? Well, 4. So 4 gets factored out, and I divide everything by 4. You don't have to show that. You can do it in your head. So what are you left with? X squared minus 5x minus, what is that? 14. Okay. Now you look in that bracket, and the bracket is a simple trinomial. So you're now knowing, okay, let me see if I can factor that into two binomials. Start with x. So I'm looking for two numbers that multiply to negative 14 and add to negative 5. Okay, so 7 and 2, which one is the negative? Negative 7, because we want to end up with a negative when we're adding. So this would be minus 7 plus 2. Okay, you can put the plus 2 in the first bracket. You can always check your answer by expanding back. And if you expanded back and got plus 5x, all you have to do is change the signs, right? Next one's already in descending order of degree. Vital that you take out a negative. You common factor out a negative because you want that coefficient in the brackets to be positive. So between 3, 18, and 24, any factors? Common factor. 3, right? And we're going to take out the negative, so we're going to have negative 3, bracket, x squared plus 6x plus 8. Change the sign, yeah. Okay, and then x there. These are all positives, which is nice. What are two factors that multiply to 8 and add to 6? Hands up. How about Hunter this time? 2 and 4. Good. Okay. Okay, next one is a tricky one. But we talked about brackets yesterday. So it says factor. It doesn't say expand or simplify. And take a look at the bracket. Is every one of those brackets exactly the same inside?
Yes.
Yes. So it's common. So we're going to factor out the x minus 3. And what's left is all of the coefficients, right? So I kind of just shade off that, and I'm left with x squared minus 5x plus 6. Now, it's a simple trinomial. X's can go in the beginning. Now, obviously, if you can't factor it, you can just erase that and say can't factor. But what are two numbers that multiply to 6, positive 6, and add to negative 5 totally? Great, good. So negative 3 and negative 2. So you might think negative 6 and positive 1, because that would add to negative 5. But negative 6 and positive 1 multiply to negative 6. So it doesn't satisfy this last part of it. Okay. Now the next question 5 is just filling in the information. So really the first one is just expanding. You don't even have to think about factoring, right? It's given factored form, expand out. So x times x is x squared, got it? X times 9 is 9x, but this is already collected, right? So now I've got to do the plus 7x. So 9x plus 7x is 16x. And then 7 times 9 is 63. So really that was an expanding question. You could do it by factoring as well, but expanding is a bit easier. Okay. Okay. Next one, we've got a box on either side. So this is expanding. So let's do what we have. X times x is x squared, so we're good. Then we will have 1 times x is x, and then we don't know what. And we don't know what it is there. But our last terms together have to give us negative 8. So what must go in the box? 1 times what gives you negative 8? Negative 8, right. And it's already got the negative, so this is going to be 8. So now when you expand out, you'll have x minus 8x, which is negative 7x. And it's already got the subtracting there, so that would be a 7. Okay, so it's really filling in the missing information. Okay, and then the last couple of questions are about algebra tiles. Remember, we talked about them. Some of you have used them before in junior high. You have to be aware. We're not going to use them per se, but you have to be able to identify an area diagram or algebra tile diagram. So it says a rectangle has this area. Determine the length and width by drawing this rectangle using algebra tiles. Well, let's think about it. I'm just going to draw a big rectangle because it's just easier than trying to do individual. Okay, and we've got an x squared, so that's going to be 1 square in there, right? That's x squared. That's the big X. Then we have 4 as the constant, and so remember that goes across. Basically, it's split into 4 parts, maybe more. But that's going to be a 4 there. So somehow in these, we have to split into those rectangular tiles, right? I'm going to erase that in a sec. But they have to add up to 5x. Okay? So it's not equal, right? We can't divide this into 2.5x here and 2.5x here. It just doesn't make sense. Okay, but these are 4 squares. So actually, I'm going to make mine look a little bit nicer, but you don't have to. If it's 4 like that, then these would be 4 little squares, right? Oh, not necessarily. Let's try it. 4 little squares. This is good learning. If I did it like this and did 4 little squares, then this would have to be a line here, and this would have to be a line here, right? So how many X blocks would I have? I would have 4. It says I need 5 of them. So what should I change this? How should I arrange these 4 little squares? No, I gotta get 4 of them, not 5 of them. So the only two choice when it kind of goes back to what we were doing. 4, we need 2 numbers that multiply to 4. 2 and 2 didn't work. What's the other choice? 1 and 4. So I'm going to expand this out. What? Because the x's that we would have to have, it looked like this, would be 4x, and we need 5x. So we need to erase this bottom part, and then expand this. Okay, so now we have 4 little squares and 5 x's. So that would be an area diagram. The length then could be x plus 4. This would be x plus 1. Yep. No. These are x's here. But that width there is just 1. 1 times x, right? These are the areas of it.
Oh, okay.
So the factored form is x plus 4 times x plus 1. So basically, like when you used actual physical algebra tiles, you move them around till you get a rectangle. Here I had to erase things till I got a rectangle. Okay. And then if it's given a diagram, it's pretty straightforward, right? These areas, so these are x squareds. Each of these is x. And these are 1s. So that whole area is 2x squared plus 3 to 6, 7x plus 3. And this is kind of interesting because this leads into tomorrow's work. Because take a look at the dimensions here. This is actually 2x plus 1, because each side of that big square is x. And then this is x plus 3. So this is not a simple trinomial. Do you have a question, guys? So this one is not a simple trinomial because it's not just 1x squared. Okay, and so we'll learn more about this tomorrow. But with a diagram like this, all you're doing is finding the length. So x plus 1 is 2x plus 1. And this side is x plus 3. And you can check if you expand that back, you get 2x squared plus 7x plus 3. This one here is 3x squared. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 x's and 8 1s. You take a look at the length, that's 3x plus 1. This is x plus 4. Okay, and if you expand that back, you will get the total area, right? 3x squared plus 12x. Oops, what did I do wrong here? Plus 2. Yeah, thank you. There we go. 12x plus 2 is 16x plus 8. Okay, and so take a look back. Notice how today we always had 1x squared. So our first terms were x and x. Now we have 3x squared. So now we have to have 3x and x. Here we have 2x squared, so we have to have 2x and x. Okay? Sometimes, though, they're not prime numbers, so you have to do a little bit of we'll learn a proper method, but you might get to the point where you can do it without all that work. But that's some patterns to it. Notice how the last terms multiply to 8, just like before, okay? But how do you get those middle terms? Because 2 and 4 don't add to 14, right? But the outside and the inside add to 14, right? So 12x plus 2x. Here, the outside and the inside add to 7. Okay, so that's where I'm going to leave it because we're going to spend more time on that. But you can practice. There's lots of practice there. Well, there's one page of practice. And then I really recommend you're doing textbook practice as well. If you take a look, that is page 166, page 195. For factoring, it's all about practice. Practice, practice, practice. Same questions over and over and over again. Okay, really important, particularly if you're wanting to go to 20-1, you have to be able to factor. Fast, fast, fast.